Hi everyone, this is question number 14 from the Chapter 3 review. Now, I've been asked by Lara to demonstrate this one, so here we go. I recommend the way you use this video is not to just watch it all the way through and see the whole solution. I recommend you watch a little bit of it until you start to get a sort of a grasp of what's going on, then hit pause and see if you can do the rest of the question for yourself. If you do happen to get stuck a bit further on, then keep playing the video a little bit longer until the penny drops, and then hit pause again and keep working through it progressively like that, so that hopefully you can solve some or most of the question for yourself without just watching what I'm doing. Now, the scenario in this question, if I just quickly recap, is that we have two friends playing a game of chance. They have a bottle filled with 5 red and 7 green marbles. So that's what I've made a note down here, the number of red and the number of green. And they take turns at selecting at random a marble from the jar. Now, it's a typical sort of a binomial experiment. There's two outcomes. You either get a red or a green, and they're taking it in turns. So this first set of outcomes sort of here, that first round of the competition, it tells us that Sebastian goes first. So I'll write Sebastian. Then Sebastian's friend Georgie goes second. It's a bit confusing to have Georgie, G for Georgie and G for green, but the ones down the bottom here are the names. Then Sebastian has a turn. Then these outcomes would be Georgie, and finally Sebastian has a turn. Now, of course, there will still be more marbles left in the container. I'm up to the 5th round of the competition, so 5 marbles would be withdrawn out of 12. Now, there's a couple of reasons why I stopped drawing the tree diagram at this point. It would be virtually impossible to keep going to 12 rounds on the tree diagram. When I was at the 12th place on the tree diagram, how many branches would there be? That would be 2 to the power of 12, wouldn't it? And that's 4,096 different little branches at the end of the tree diagram. There is no way I would be able to draw a diagram as good as that. Now, here's the second but much more important reason why I can stop after 5 rounds. And this is a big enough tree diagram anyway. The next reason is because the rules of the game say the person who wins is the first one to get 2 marbles of the same colour. Now, let's just imagine that the first marble came out was red. Then Georgie has a turn, not sure what she gets, could be either. Then the next marble came out for Sebastian was green, so he hasn't won yet. Then the next turn is Georgie. Georgie takes another marble, but it doesn't match. It's the opposite of what she had over there. And then here comes Sebastian. Now, he could get green or red on the 5th turn. If he gets a green or a red, he's going to win because he already has one of each colour. Now, if the game gets to 5 rounds, then Sebastian will clearly be the winner because he can win with either colour. Doesn't matter which one he picks. Now, there's no point going beyond that because anywhere beyond that, well, the game's already finished. The game's already been won. So this is the second most important reason why I didn't have to draw the tree diagram beyond 5 rounds. Now, that sort of hints at the next little part of the question. So if you want to pause here, having seen the tree diagram, and then try to take it from there, be my guest to hit pause and carry on. But if you're coming back, then here is the next sort of part of the thought process. I'm going to trace my way through the tree diagram now, and I'm going to put a circle. We're interested in the chance that Sebastian is the winner. So clearly Sebastian cannot win after the first round. He only has 1 marble, red or green. Then the second round is played. Georgie selects a marble, and it'll be one of these ones here. Now, she's only got 1 marble. She can't win. The first time that anybody could win would be the 3rd round, and that would be Sebastian. So if Sebastian happened to pick red on the first one, then say Georgie picked red, and then Sebastian picked red on this one, he would win. He would win at that point. Now that means the subsequent rounds, I'm just going to increase the size here a bit, that would mean these subsequent rounds here wouldn't get played. They wouldn't actually exist. My tree diagram can be pruned. I can chop that off. If the first round goes red for Sebastian, then red for Georgie, then red for Sebastian, he wins. Now what about if we go this way? Red for Sebastian, red for Georgie, no one's a winner yet. Green for Sebastian, he's not a winner yet. Now perhaps we go red for Sebastian. He is not a winner. Yes, sorry, he is a winner at that point, isn't he? Because he had a red one. No, I'm getting mixed up. Sebastian is round 1 and round 3. They're different. Georgie is round 2 and round 4. Now, if it is red here, let me highlight that one in blue, because that means Georgie wins. Now, again, we wouldn't have to do the subsequent turn. That's a terminal branch of the tree. I can prune those extra ones off, but it's not a win for Sebastian. So it's not an outcome that we're looking for. But that's okay. We can do that. Now let's go back to yellow for a minute. Say it was red for Sebastian, red for Georgie, green for Sebastian, green for Georgie. So Sebastian's had one of each, Georgie's had one of each. On the next outcome, this is what I was talking about earlier. It doesn't really matter if Sebastian picks red or green. If he picks a red one, then he already had a red one back in round 1. He has 2 the same. If he picks a green one now, he had a green one from round 3. He has 2 of the same, so both of those are winning outcomes. Now, this is probably another good place to pause the video, because that's a bit more of a clue about what's going on. Now, you would have to pause the video now if you want to take it from there. Okay, and now we're coming back to continue. I'm going to continue working through the rest of the pruning that's required for this tree. So just to make it clear, I'm using yellow down here to represent Sebastian winning, and I'm using blue highlight to represent Georgie is winning. And I'm only highlighting the points where they actually win the game. So let's go into this next set of branches. Red for Sebastian, then red for Sebastian. So that's clearly a win for Sebastian. I can erase quite a bit of those little terminal branches in there to make my life look easier. Now, what happens if we go down this next branch to here? So Sebastian had red, then green. He's got 1 of each. Georgie could go to here and get, so Georgie was green there, Georgie was green there. That means Georgie is the winner. And we would not play those rounds there. Now what about this branch? That's a red and a green for Sebastian. It's a green and a red for Georgie. No outcome yet, which means both of these are wins for Sebastian. So there's a bit of an advantage here. I think even at this early stage we can see there are more possible outcomes for yellow, which is Sebastian, than there are for Georgie. Poor Georgie, she played second. She's a little bit disadvantaged as a result of that. Hopefully they threw a coin or something to decide who went first. Now then, this would be another good place to pause if you wanted to continue pruning the rest of the tree for yourself. Okay, so in case we're back again, here we go pruning the remainder of this tree. So again, yellow for Sebastian. Got to be careful, I almost said Georgie there. That's a green marble, followed by a green one for Georgie, followed by a green one for Sebastian. So if I start from the outside, I can then say Sebastian has 1 with 2 green marbles. Prune all of those little branches away there. Now what about the next one? A green followed by a red, no outcome at this point. Now if Sebastian, then this is Sebastian on his next turn, if he got a green, I need a yellow then, don't I? If he got that green, so there's a green one, then wait a minute, I just messed that up, didn't I? The importance of concentration cannot be overstated. Let's try that again. I wouldn't want to ruin this after such a lot of effort. So, Sebastian got a green. Then he got another green. He's the winner. A green, then a green for Georgie, then a red for Sebastian. No winner yet. Now on the next turn it's Georgie. If Georgie gets that green, she's got 2 greens. Georgie winning is a blue colour. And let me prune the little branches there that don't apply. Now what if we went to here? So Sebastian had a green and a red. Georgie had a green there and Georgie had a red there. No outcome yet. Now we're in the same scenario where both of these would be winning outcomes for Sebastian because he had a red one and he had a green one in round 1, red one in round 3. Either colour in round 5 makes him the winner with 2 colours the same. We're almost finished. This gets tricky, so yep, concentration. Wow, how important is that? Green, red. Now, if we end up here that Sebastian chooses that, or luckily ends up with that green outcome, then yes, he has a green followed by a green. All of those bits can go away. What happens for young Georgie? So perhaps he got a green and a red. Now Georgie had a red. If she got that one, she has a red from round 2 and a red from round 4. She wins. Take those bits out. And the last one would be the same scenario we've described before. Sebastian wins with, he has a green in round 1, he has a red in round 3, and either one in round 5 make him the winner. Now we have completely pruned the tree so that all of those little terminal branches where they stop have an outcome. There's a winner from the game. If you'd like to pause now and take it from there, you could try to figure out the rest of the question. Okie doke, welcome back. So the next part of this is we're looking at the, obviously there's no replacements going on. So that's a bit of fun, no replacement. Now we're going to start writing down the different ways that we could solve this. We could go, gee, the probability of, now let's go from the top here, we could have red followed by red followed by red. That's not a very neat letter R there, is it? Or we could have, so I'm looking for the yellow ones, we could have red, red, green, green, red, 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 green, green, red. Or we could have red, red, green, green, green. Or we could have, now we've only done these 3. We'd have another 3. That's 6, 7, 8, 9, 10. There'd be 12 of these things. We'd have to have 12 of these possible things all listed out there. That would work. We could calculate them. And if you wanted to keep going with that, you're welcome to give it a try and pause the video. But that's a bit mean. Don't pause the video. There's an easier way. Look at that. Look at what's going on here. There's only 4 outcomes here for the blue. So let's take that away because that is a possible way to solve the question, but it's a long and difficult way to solve the question. So what about if we start with the idea that the probability that Sebastian wins, that's the complementary event of Georgie winning. So I can go 1 minus the chances that Georgie wins. Now, how many ways are for their Georgie to win? Well, there's only the 4 little blue ones there. That's less work. Well, I like the sound of less work. I hope you do as well. So I could have, let's see, how's the first way that Georgie wins? Red, red, green, red. Red, red, green, red. Or we could have red, green, green, green. Or we could have green, red, red, red. or we could have, what's the last one? The last one is green, green, red, green. I think that was it. Green, green, red. Yes. Now that looks like a lot less work to me. And I probably should make a note that, you know, all of these things have to be added together before subtracting them from 1. Now this red, red, green, red business. Well, if we went along here, there are, on that first branch, there are 5 red marbles to pick out of 12. Now this is where we've got to be a bit careful. No replacement. On this next little branch here, we've already had a red one. There are 4 red marbles left to pick out of 11. Then we're coming down the green branch. We still have all 7 of them, but there's only 10 marbles left in the bag now. And the last one, there'll only be 9 marbles left in the bag. And where did we go? We went green, then red. So we're picking a red one. We've already picked 2 red ones out of 5, so there'd only be 3 left. Now that is the red, red, green, red. Red, red, green, red. There it is. Boom. Plus, we want red, green, green, green. Well, there were 5 reds out of 12. Then there were 7 green ones out of 11. Then 6 green ones out of 10. Then 5 green ones out of a possible 9. You could go back to the tree diagram if you like, but the RGGG is the bit we needed. So we're trying to get to this blue terminal, RGGG. Now what's the next one? Just above here, green. There were 7 green ones out of 12. I think you can see the pattern. Each time we draw another marble, there's 1 less in the container, so it'll be 12, 11, 10, 9. Now the green one, there were 7 to start. Then the red ones, there would have been 5 to pick on this draw, then 4 available, then 3 available. Lastly, we've got green, green, red, green. So we'll have 7 over 12, 6 over 11. The red one here is a bit of a spanner in the works. There are 5 of them out of 10. And now the green one, it sort of skips a step from there to there. There were 7 green, then 6 green, and there'll still be 5 green at this point. Well, there's another opportune place to pause the video. And I'm sure you can pop all of that into your calculator and you'll find a fraction here with something over something, and then your final answer of course will be 1 minus the something over something. So that'll be a very exciting moment there. There'll be fireworks and there'll be cheers and everybody will be happy when we finish that. So I'm not going to finish that because I don't want to completely do the whole question. If you've got to this point, well done. If you paused earlier and finished it for yourself, excellent job. Okie doke. That's it for that question. What a nice question. Thank you for asking that one, Lara.